Hello, boys and girls, and welcome to today's math lesson. Today, we're going to be doing some more word problems, and we're going to be talking about that missing number that's the second number in the equation. So let's go over our I can statement. I can represent and solve addition and subtraction problems within 20 with unknowns by using objects, drawings, and equations with a symbol for the unknown number to represent the problem. So yesterday we talked about addition word problems with that change unknown, so that second number that was unknown, that missing add-in. Today we're going to be talking about subtraction word problems with that missing number. So all last week you were going over all of that missing number stuff with Mrs. Zalaki, and this week we're going to apply it to our word problems. But before we get started, get out your math notebook and a pencil, and we're going to solve a couple problems, and then we'll hop right into it. The first problem I want you to write at the top of your notebook is 10 plus unknown equals 13. Now, to solve this problem, I'm going to go ahead and I'm going to use a picture. So, kind of like that picture that we talked about yesterday a little bit. It's like a chart, and Mrs. Zalaki went over it with you. It's in your workbook. So, now, the bigger number, the sum, right, what's in all, goes down here. It's 13. And then one of your numbers goes in one of the boxes. So the first number goes in that first box, okay? So this is the number 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you're looking at how many you need to count on in order to get to 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, how many did I write in this box here? That's right, I put 3. So it takes 10 plus 3 to get to 13. Okay, I have my equation, I have my strategy, and I have my answer. Next one, 20 minus unknown equals 15. So for this one, I would like you to go ahead and we're going to do an open number line. So remember, in subtraction, you start on that far right-hand side. This is where you start, right? You start here. Off to the races. This is how many hops you do, okay? And then this number here is what you hop to. So I'm going to see how many hops it takes to get to the number 15. 20 minus 1 is 19. 19 minus 1 is 18. 18 minus 1 is 17. 17 minus 1 is 16. Still not 15 yet. 16 minus 1 is 15. Now we want to see how many hops we took. 1, 2, 3, 4, 5. So it took 5 hops, which is what I'm looking for, to get from 20 minus unknown equals 15. So 20 minus 5 equals 15. That is exactly how you solve that problem. All right, let's hop right into our lesson. So for your subtraction equations, you are going to be solving and finding that missing number. What's important is that when it is the second number that is missing, the unknown number goes in this first part of this box. So this said 4 minus unknown equals 1. 4 was the total. 1 goes here. And then you figure out that this is 1, 2, and 3, 4 equals the total number. So 4 minus 3 equals unknown, or equals 1. I apologize. If you'd like to follow along, Okay, this is in chapter 3 of your Big Ideas Volume 1 on page 134. So if you want to go ahead and pause this video, go and get Volume 1, Big Ideas Math, on page 134. Okay. So we're going to do a couple problems together, and then I'm going to go over your seesaw activity with you. For question number 1, this says 7 minus unknown equals 2. Okay? 7 minus unknown equals 2. To solve this, you want to make sure that you understand that 7 is the total number, because in subtraction, this number here is the biggest number, right? So like in a part whole, this number here is your whole. So I see that I have 2 left. Well, I want to know how many I took to get to 2. So you could always solve this without this and do an open number line. Or you'd have to take 2 and count on to 5. On to 7. I'm sorry. 2, 3, 4, 5, 6, 7. And you'd see that you have 1, 2, 3, 4, 5 circles here. So 7 minus 5 equals 2. Okay. Let's go ahead and let's solve question number 2. Same thing. 5 is your total, your whole. It's the largest number. The first number in a subtraction equation is your whole minus your part equals your part. Okay? In addition, it's part plus part equals whole. So this is your whole number. 3 plus some number is going to equal 5. Or 5 minus some number is going to equal 3. So you could always do 5 in your head and count back till you get to 3. So 5, 4, you'd have to do 5, 4. So you literally have to do 5. So this is your whole number. This would be 5, 4, okay, 3, 2, 1. And you can't really see that because, of course, it's in red. 3, 2, 1. So 1, 2, 3, 4, 5. I think it's easier to count on or to solve with an open number line. Because if you solved with an open number line, this is 5. This is your start number, right? This is your hop 2 number, and these are your hops. So if you started at 5, right? And then you're trying to figure out if you hop back to 3, and then you would count your hops, and you would see that you're missing 2. I think this is easier than this. 5 minus 2 equals 3. Okay? But you can always count on with this, filling in the part whole or this missing number chart. All right. Now I'd like you to go ahead and we're going to do one last problem together, which is more similar to what you're going to do for your lesson, your activity on Seesaw. So go ahead and turn to page 136. And we are going to look at number 8 right here, the show and grow with the box of crayons. So this says you have 8 crayons. You lose some of them. So you don't know how many you lose. You have 2 left. How many crayons did you lose? So you have 8, right? You lose some of them. Well, we know you lose them, so it's subtraction. We don't know how many you lose. And you have 2 left over. So how many did you lose? Now, this is a blank part whole chart. Your whole, don't forget, whole minus part equals part. This is your whole number because it's the whole total number of these two parts added together. So 8 goes here. Your part, you know, one part, right, is 1, 2. Well, we're missing this other part. So I'm going to go ahead and I'm going to count from 2 up to 8. So I have 1, 2, 3, 4, 5, 6, 7, 8. Or you can do 8, 7, 6, 5, 4, 3, 2, 1. Okay? You could also solve this problem with an open number line. Okay? You know, Mrs. Cooper, she loves her open number lines. You're starting here at 8, and you're hopping back, remember, till you get to 2. 8 minus 1 is 7. 7 minus 1 is 6. 6 minus 1 is 5. 5 minus 1 is 4. 4 minus 1 is 3. And 3 minus 1 is 2. Now I would count my hops. 1, 2, 3, 4, 5, 6. So I lost 6 total crayons, as you can see in this picture. 6 is my missing part. 1, 2, 3, 4, 5, 6. I lost 6 crayons. So those are a couple different ways to solve those word problems. So now what I'm going to do is I'm going to show you your seesaw activity. Okay, so your seesaw activity is on pages 37 and 38. This is an example. Obviously, you can see I like my open number lines, and I showed you, let me make sure I'm sharing. Okay, I showed you your open number line strategy as a way to solve, because I do think it's easier with subtraction in particular. Okay, you will be solving these problems. If you'd like to, and you're solving them in your workbook, that's fine. And you have room, I double check with an open number line. If you're solving them on here on the template, I would solve them with an open number line to double check your work. It's great practice. There's no wrong practice. It is fantastic practice. So do not think that it is poor practice. It is fantastic practice. For numbers 3 and 4, you're solving it on your own. So you're giving me finishing that equation, making sure I know the answer, and giving me a strategy. I don't want to just see the answer here. I want to see strategies for 3 and for 4. Same thing for number 6. I should see an equation, the strategy, or an open number line over here to the right, the answer. Okay, remember, elephants sing always, ESA. I put that on, oh, actually, that's on a later lesson. So let me go over that real quick. I always teach my students this, ESA. When you're solving an equation or a word problem, let me take you off share screen so you can see this better. When you're solving a word problem, I always teach my students that elephants sing always. So it's a trick to remember. You want to have an equation, elephants, okay? So here's my best elephant. There you go. Elephants. Strategy, sing. So sing is the strategy. Okay. Elephants sing always. Always is the answer. So in a word problem, I always want to see your equation, right? That might not be an example of what your equation is. The strategy, so you're either drawing like those circles where you're taking away something or you're adding something, or an open number line. And then I see that you put your answer. Okay, so I want to see that you know what the answer is or what you were looking for. So equation, strategy, answer. Elephants sing always. It's a great way to remember. Trust me, I used to teach my second graders when I taught second grade, and I even taught my fifth graders that trick when I taught fifth grade. So it's great for any student to remember for the rest of your school career that you need an equation, a strategy, and an answer. Thank you so much for joining me today. If you need to, come back and pop into this lesson. If not, I'll see you next time. Thanks so much, boys and girls. Bye.